Welcome to the second cyber physics video clip on the subject of reflection in a plane mirror. Today we're going to look at an easy way to construct the diagram that shows how an image formed in a mirror is not only virtual but laterally inverted. When you look into a mirror, you see each point on your face as far behind the mirror as it is in front. But the points on the left-hand side of you become points on the right-hand side of your image, and vice versa. Your image is not inverted, but laterally inverted. The sides are the wrong way round. You're not upside down. This makes reflections of writing look strange. This video will show you how to construct a ray diagram that demonstrates how the laterally inverted image is formed. We are going to produce an image of the letter L. To define the letter, we will have 3 points from which we will take 2 rays and construct their image points. These can then be joined together to give the image of the letter. First, draw the mirror symbol. Next, draw your letter, put it at an angle, it shows the effect more clearly. Now mark 3 object points on your diagram. I suggest you use a different colour for each point. We have now reached the point where you have to cheat. Put your image points in as far behind the mirror as the object points are in front. Using colour helps you to do this. We have to take 2 rays from each point to find out where they will appear to come from. It is the crossing of rays or construction lines that specifies the image point. If we only draw 1 ray, we cannot support drawing the image point in at any point on the construction line. Well, not without admitting we're cheating anyway. Using colour for each of the points makes the image easier to understand when it is finished. Don't forget your normals. You can now label the diagram and join up the image points to make the final image. It is evident that it is a virtual image because the actual rays do not cross, they diverge. It is by tracing them back that the eye perceives an image at the image point. It is evident that the image is erect. It is not upside down, it's the right way up. It is also evident that the image is laterally inverted. Right is left and left is right. The final point that you have to make is that each point on the image is as far behind the mirror as the object is in front. That seems to be a bit of a pointless thing to say because we cheated and made it so. But if you had constructed it properly, using your protractor, you would have found this to be the case. It is only because it is fiddly to do that teachers have thought of a way of how to draw optical diagrams that makes the whole thing easier.